Hi everybody, I'm the greatest living inventor, and today we are doing my invention, polar shift pacemaker. So let me write it down. Polar shift pacemaker. Okay, so this is very long, it's 11 pages, so I will read quickly through it and I hope we'll succeed in time. Preventing polar shift. I'm not explaining what it is, you can see it in every prepper movie. It's the rotation of the magnetic field of the Earth, and then its destruction, it leads to extinction. Preventing polar shift by stabilizing the Earth magnetic field with steady magnetic pulses in the north and in the south magnetic poles. This invention stabilizes Earth's magnetic field, so we prevent the polar shift. Background. Our lives depend on Earth's magnetic field. Earth's magnetic field protects us from deadly radiation. Look what happened to planet Mars, who's lost its atmosphere because it lost its magnetic field. Sorry, I'll take off my jacket. Look what happened to planet Mars, who lost its who lost its atmosphere because it lost its magnetic field. Here are two articles about what happened on Earth in the past. All the links I will put down in the video description, so I'm not writing anything. Ancient Earth's weakened magnetic field may have driven mass extinction. This is from Scientific American. And another one, Earth's magnetic flips may have triggered mass extinction. This is from Discover magazine. Today there are indications that we are in the beginning of one of Earth's polar shifts. Does this mean the poles must switch places? No. This means that the Earth magnetic field gets scrambled up and then builds up again and chooses its direction randomly. Okay, either this way or that way. You can see this point of randomness explained in minute 8:50 of this video on YouTube. Is Earth's magnetic field reversing by PBS spacetime? Okay, so I'm just writing this because it's important. It will be on the links with everything else in the video description. Is Earth magnetic field is Earth's magnetic field reversing? Okay, this is by PBS Spacetime. Okay, it's on YouTube, you can see it. I will give you the link in the description. Okay, so in minute 8:50 of the video you can see it. You can see this point of randomness explained in minute 850 of this video on YouTube. This is an important point for my whole solution, because first we should try to prevent the scramble up as much as we can. But even if we cannot prevent the existing magnetic field from collapsing, we can still save ourselves if in that instant that it collapses we are already there with an active guiding field in the correct orientation, the orientation that humanity is used to. We help the planet to make not a random choice but a biased choice for the orientation of the magnetic field. Can we affect the field from the outside? Okay, so another can we affect the field from the outside? Yes, we can. We use two electromagnets, one coil around the top and one coil around the bottom of the globe. See of the Earth. See in this video on minute 5 and a little before, spinning sphere of molten sodium by Veritasium. Spinning field of molten sodium by Veritasium. Okay, and this is, you should see minute 5 in the video. So we can affect it from the outside. How to build the biggest electromagnet ever? Okay, so I'm erasing this. So the rest of the video now will be on how to do it, because we see that we can and we should. So now it's the phase of how to do it. How to build the biggest electromagnet ever. How to build the biggest electromagnet ever. Okay. So a fixed magnet is not strong enough. We need to build a huge electromagnet. So I'm giving you a link to electromagnetic coil in Wikipedia. And also magnetic field, 60 symbols by 60 symbols. Okay, I'm not writing everything. Everything will be in the description of the video. And also to Wikipedia, Earth magnetic field, Earth's core and the geodynamo. Okay, so this will also be in the links. The Earth's field originates in its core. This is a region of iron alloys extending to about 3,400 kilometers. The radius of the Earth is 6,370 kilometers. It is divided into a solid inner core with a radius of 1,220 kilometers and a liquid outer core. So in the middle, between 1,220 and between 3,400, we have 2,310 kilometers, which I assume is the effective width of the Earth's magnetic field. Okay, so I'm drawing this for you really quick. Okay, this is the Earth. Here is the center of the Earth. Here is the core. Okay, this is solid core. And this is 1,220. Kilometers. No, I'm sorry, we're talking about the radius. Sorry. So let's do it in another way. This is 120 kilometers. This is the middle. This is 3,440. Kilometers, and from here to here, and between them this is let's do it in another color. And this can you see the difference? Oh, you can't see anything at all. Wait, I'll close the... Okay. Oh. So between them I'll do it in red. This part is 2,310 kilometers. Okay, kilometers. Which I assume is the effective width of the Earth's magnetic field. So this is solid, this is solid in the inside, and then there is a outer core which is liquid, and the liquid is 2,310 in this side kilometers. Okay, now 3 rings. First ring on the ocean floor, second ring on the water, third ring on the clouds. Okay, so three rings. Let's do them by colors. So the one in the ocean will do in blue. First ring, ocean floor. Second ring, or maybe we'll do them this one at the bottom because it's the lowest. Okay, so first ring, ocean floor. Second ring. I'm doing this like it's Earth because it's on the level of the Earth, of us. Second ring, so it's brown. Second ring. On the water. Okay, this is ground level, and third ring on the clouds. I'm doing this in light blue because it's in the clouds. On the clouds. Okay, so these are our three rings, and basically they will be if Earth. Let's do this in brown, in black. So if this is Earth, and let's say we have the sea, and we have a ship here, and we have the clouds. So the first ring will be in the bottom of the sea. Okay, this is this one, the first ring, ocean floor. The second ring will be on this height on the water of the ocean, and the third ring will be above the clouds. Okay, so this is our rings, and the same we have in the South Pole. We have the ocean floor, We have the ground level on the water, and we have the sky on the clouds. Okay? And this will be one magnet, this will be another magnet, and they will affect this magnet. And they need to be in this size, this like the double of the radius. I don't remember the name of the word, but this side of the circle, okay, 2 times the radius, because we need the diameter, okay. So the diameter should be like this, because we want it to affect the Earth's core, this part of the Earth's core. Okay, so this is from the side. So everything we talk about looks like this from the side. Okay, so now we begin. I'll erase this and I'll start explaining. 21 minutes and a half. Okay. 3 rings. First ring ocean floor, second ring on the water, third ring on the clouds. So what we need is 1 ring lies on the ocean floor, which is 4 kilometers down. Okay, here is 4 kilometers. Another identical ring that's floating on the surface of the water on hardened ice platforms, and another identical ring that is floating in the air using airships. Each ring has a radius of 2,310 kilometers, which means the perimeter will be 400-500 kilometers. Okay, so if the radius is 2,310 kilometers, then the perimeter is 1,400, 14,500 kilometers. Okay, so you can check this with the mathematics of 3rd grade. Okay, so this sounds really big, but we need to remember that humanity already lay several copper cables on the bottom of the ocean, Atlantic Ocean, and this cable was on the Atlantic Ocean was 2,500 miles, which is about 4,000 kilometers long. And you can see in Wikipedia, Transatlantic telegraph cable. So 14,500 divided by 4,000 is 3.625. So let's round it up. We need 4 cables made of copper wires coated in plastic to make each ring. Okay, so 4 cables like what we did in the 19th century. So of course we can do it today. First ring, the underwater ring. Each cable is, okay, so I'm erasing this, you'll see the whole picture. Now I'm talking about this ring. I'm erasing these two. Okay, you remember this: first ring on the ocean floor, second ring on the ground level, on the water, on the ocean, not in the ocean, but on the ocean, and third ring on the clouds in the sky. Drink something. Okay, sorry. So first ring, underwater ring. Okay, so now we are talking only about this ring inside, in the bottom of the ocean. Each cable is laid down between big ships that will be dedicated to this mission. The ships are also our nuclear power plant, power station. Okay, so if we have the ocean, and all this is the ocean, and this is the bottom of the ocean. Then we have ships. Okay, this is one ship. And this is another ship. And they have the cable is going from the ship. Okay, the copper cable, let's make it in brown. I have also light brown, let's check it out. Okay, and the cable runs until the next chip. Okay, so I hope it's okay. So this is the cable, copper cable. Each cable is laid down between big ships that will be dedicated to this mission. The ships, so they are always here. Okay, they don't move. The ships are also our nuclear power plant, power station. Okay, so we have, I don't remember how to draw the symbol of radioactive, but it's like something like this and like this. Okay, so it's nuclear ships. And they give the power to the pulses of the electricity that makes the electromagnet. Okay, and of course there are other ships, like here it continues. There is another cable and another ship and another cable and another ship all around the tip of the, if this is the tip of the, like this is the North Pole, so all around the North Pole there are ships arranged in a circle, and from here also another cable going to the next ship towards you and towards the board. It's a circle. Okay, so this is the circle. This is not the circle, this is a straight segment. I'm just painting this close, but they are far away, and here there are 4 kilometers. Okay, this is like 3.5 kilometers. Okay, can you see it? Yeah, okay. So each cable is laid down between big ships that will be dedicated to this mission. The ships are also our nuclear power plant, power station. So our electricity comes from nuclear ships like the Russian Yamal, for example. Okay, Yamal. You can see in Wikipedia. Which my parents cruised aboard to the geographical North Pole, where Santa lives. By the way, Yamal itself cannot pass the equator because it needs the cold water to cool down. So we need to build ships like Yamal down in the southern hemisphere for this project. Okay, so you can see it in Wikipedia, Yamal icebreaker. So, just like the transatlantic, okay, this is an icebreaker. Which you can see in Wikipedia. Just like the transatlantic telegraph cable, this cable lies on the ocean's bottom. If you look at the whole thing from above, from the bird's eye view point, there will be 4 ships in a circle. Like if the surface of the sea is the surface of a clock, then the 4 ships are stationary in the 3 o'clock, 6 o'clock, 9 o'clock, and 12 o'clock. Okay, so what I mean is, like there is 1 ship here, 1 ship here, 1 ship here, 1 ship here, and they make a circle around the North Pole. And also the same around the South Pole. 4 ships there. Between every 2 ships we have a cable that goes from the ship down to the bottom of the sea, 4 kilometers down. Okay, this is 4 kilometers down. And where the cable reaches below the next ship, it comes back to the surface 4 kilometers up. Okay, so this is, sorry. Yeah. 4 kilometers. And also 4 kilometers. Please note, please note, in our case, the coil is not like a spring. Instead, the rings are separated. Okay, so we talked about it, that we have the bottom ring at the bottom of the ocean, and we have the ground level ring on the ocean, on the waves, and we have the sky ring in the sky, on the clouds. Okay, but so you might ask yourself, normally we when we talk about a coil, it looks like this, right? But this is not like this. But still it works the same, because the important thing is that they will, the electrons will move in the same time. Okay? If the electrons spin here and spin here and spin here at the same time, it acts like this. This is just the comfortable way to do it practically. But if you have a way to synchronize this with atomic watches, with atomic clocks, then this works like this. Please note, in our case, the coil is not like a spring. Instead, the rings are separate. But for the sake of the electromagnet, this doesn't matter. As long as the electric pulses in each of the rings are synchronized between the rings, which we can do with a very accurate watch, like an atomic clock, this is also how we synchronize between the 4 ships. Okay. This ring, first ring, underwater ring, is special because unlike the other rings, we cannot put fans or something like this to take the heat away by convection. Okay, this gets hot because big current of electricity goes through this, so it gets hot, the cable. And we cannot put fans or something like this to take the heat away by convection. Also, the ambient local environment temperature is not colder than 0 Celsius, or else the sea would freeze. It would have been more than 0, but the water is very salty, which brings it down, the temperature. The other 2 rings in colder environments and with convection flows by natural wind or by drones with fans that we deploy. Third ring is the stratosphere ring, or boats with fans on them. Second ring, the water surface ring. So the way we solve this is by redundancy. We have more than 1 wire underwater between every 2 ships. We let them rest in shifts. Okay, so we have another cable here. Let's do this one in this color. So magenta. So we have another cable coming from the ship, which goes in the same way to the same other ship. Exactly the same, but you know, like they say in Thailand, same but different. Okay, so it's like, it's another cable that if this one is hot now, then we use this one. If this one is hot now, we use this one. Okay, so we have redundancy. Redundancy. Okay, redundancy cable. This gives the other cable time to cool down. In the meantime, we use this one, and then we change to the other one, and this one cools down, and the other one is hot, and so on. We have more than 1 wire underwater between every 2 ships. We let them rest in shifts. One time this one, the other time this one, and only use a cable once. And only use a cable once it cooled down. The cooling down is done through the copper wire itself, as I explained in the section about the electrical resistance problem and the pulsed direct current solution. Okay, so we'll get to this. Okay, 39 minutes, so I need to hurry. Okay, second ring, the water surface ring. So I'm erasing this. Second ring. water surface. Okay, this is the brown ring on the waves. Okay, so now we look at on the wave surface. And we have two ships. Again, nuclear power ships. Okay, so and we have we want to make a line between them. Okay, so we have I'll read it to you and then I'll paint. Second ring, the water surface ring. To hold, can you hear me? Yeah. To hold the upper ring floating, we can produce, okay, the upper ring, I mean this one now, we can produce many platforms of Pykrete, which is ice with 14% 14% sawdust, or some other form of wood pulp, such as paper, which is as strong as concrete, but has the advantage of floating on water. So you can look in Wikipedia, Pykrete. So we have platforms. Let's do this in brown because it's made out of Pykrete. Okay, it's a lot smaller than the boats, but I want you to see this. Okay, so and then the cable is lying on these platforms. Like many platforms of this. For this ring, we are on solid, although rocking back and forth, ground, and we are on the sea, but we are not like in the air. That's what I mean. And it's relatively easy to reach and maintain. Here I suggest we use traditional cryogenic refrigerators like we would use in a laboratory. Okay, so you can see cryogenic refrigerators in Wikipedia, Cryocooler. Okay, this is in Wikipedia. I'm not explaining. For example, something like this, which we put on each of the ships. Helium-3 refrigerator. Sorry, I don't have time to explain. The way we transfer energy from one platform to the next, okay, from one of these to the next, can be, let me paint two of these, okay? This is Pykrete. I'm erasing one and making two because we have many. I'm just giving an example. Okay, so, and here it's long, okay? There is a long distance. Again of like 4 kilometers, about 4 kilometers, 3.5 kilometers. The way we transfer energy from one platform to the next can be using resonant inductive coupling. See in Wikipedia. Okay, so here, sorry. Okay, these are exchanging energy in resonant inductive coupling. Which again, I'm not explaining, you should see this in Wikipedia. I don't have time, sorry. In 2007, a team led by Martin Soljacic at MIT Martin Soljacic at MIT used two coupled tuned circuits, each made of 25 centimeters self-resonant coil of wire at 10 megahertz to achieve the transmission of 60 watt of power over a distance of 2 meters, 6.6 feet, 8 times the coil diameter, at around 40% efficiency. Okay, this is, you can see this in Wikipedia, in wireless power transfer, near field, non-radioactive technique. Okay, I don't have where to write it. Wireless power transfer. In Wikipedia, under the section Near Field Non-Radioactive Techniques. Okay, so you can see it in Wikipedia. I'm not explaining. Sorry. So I suggest we will have again redundancy with one system charging up until a battery into a battery or capacitor, while its sister system is delivering the pulse, and then they switch. Okay, so we have two of these here. Okay, this is the second one. And when this one is working, and after this one is working, that one is working, this one is working, okay, and they have a battery. Okay, like a battery that you use every day, only big. And they charge or capacitor, and they charge into this, I don't know electronics, maybe you draw capacitor like this, I'm not sure. But anyway, when it's full, then you use it. And after this, you use the other one, and this one gets filled, and you use them one time this one, the other time that one. Okay? Okay. What's the time? 50 minutes. Okay, it's really bad. I will hurry up. So I suggest we will again use redundancy with one system charging up into a battery or a capacitor while its sister system is delivering the pulse, and then they switch. Okay. Third ring, the stratosphere ring. Third ring, stratosphere. Ring. Okay, I'm doing this really fast now. The idea of airships carrying a cargo is not so Hindenburg disaster as it sounds. So this, see this recent article. Using the jet stream for sustainable airship and balloon transportation of cargo and hydrogen. Okay, I'm putting this in the links with everything else. Also the troposphere, where all the weather and storms ends at 6 kilometers up in the Arctic region, where we need this project, and also the Antarctic, of course. So there are no lightning, wind, etc. Okay, we are above the weather. No. The main problem is we can't have heavy equipment like the equipment to maintain high pressure for the superconductivity of the copper wire. I will explain why we need high pressure later. Still, we have low ambient temperature, according to Wikipedia, -70 to -75 degrees Celsius at the tropopause, which is cool, pardon the pun. Perhaps the whole wire can be inside a sleeve made of tarp, which will be filled with lighter than air gas, so it keeps itself afloat, but also the gas is compressed using a pump at the end of this long balloon / sleeve. Okay, so you can see in Wikipedia tarpaulin. Okay, so what I'm suggesting is that we have some balloon and here a pump and there a pump. I'm sorry, I don't know how to draw a pump. And then the stratosphere ring, the wire above the clouds will be here inside this. Okay, and this thing keeps it float because it's filled with something light. This ring also has the magnetic attraction to the rings beneath it, which is both a blessing and a curse. On the blessing side, it keeps the clouds ring, the third ring, from drifting away. On the downside, it pulls it down strongly for a microsecond each time. This pulling just means we need more pull-up force, like the more airships holding the ring. Okay, so this is connected to airships. Okay, so this is connected to airships. Like Zeppelins or something, but of course small. Okay. The way we bring the electricity to this ring, the third ring, Stratosphere ring, from the ships, okay, from the ships that we have here. Remember, we have the ships. Is using microwave beam. Okay, so we use microwave beam. Again, not explaining, sorry. Microwave beams can transfer energy even to and from outer space. Okay, you can see in Wikipedia in wireless power transfer, far field radiative techniques. Okay, not near field like we've talked before. Now it's far field, far away. Okay, problems, resistance, magnetic field. Okay, so I'm erasing this. Okay, I really hope this will be in time. Problems. Resistance. Stabilization. And solutions. Pulse direct current. And pulsed magnetic field. Okay, so I'm rushing through this. I hope you understand something. So we want to make a coil and run direct current DC through it. Problem 1. Regular direct current DC creates a lot of electrical resistance. How can we make the current flow through the long pieces of wire? You can see in the 60 minutes video that normally powerful electromagnets are cooled to a temperature close to that of the absolute zero, so that they have superconductivity in the wire. No resistance in wire means huge current, which means huge magnetic field. Problem 2. Heat means vibrations, movement of the tiny particles. The upper ring is standing on floating platforms, okay, the middle ring, which rock on the rough waves. How do we keep these shocks from vibrating the wire? Sorry. The way we solve both of these problems is by using pulse field magnet. Okay, you can see in Wikipedia. And pulsed DC. You can see in Wikipedia pulsed DC. This means that in each ring we do not flow electrical current continuously, but instead we do this in short bursts. Between each burst we connect the copper wire, which is also a very good conductor of heat. You can see in Wikipedia copper conductor, thermal conductivity. So we connect it to a cryogenic refrigerator, which we talked about, cryogenic refrigerator with helium-3, remember? Between each burst we connect the copper wire, I read this. This brings the temperature of the copper wire through heat conductivity, diffusion, through the wire, to a temperature which is closer to the critical temperature needed for a superconductor. Now, we are talking about the first ring on the ocean floor. When we add this cooling to the high pressure under the sea, when you ask Wolfram alpha, pressure at depth of 4 kilometers, you can get the answer 39.33 megapascals. I'm not writing because I will not be able to do the video, sorry. Then you can get something that is close to a superconductor, because superconductor requires either extremely low temperature and regular pressure, or a combination of very low temperature and very high pressure. Okay, so you can see in Wikipedia high temperature superconductivity and room temperature superconductor. Combined with the short bursts, pulsed DC, this gives us effectively a superconductor. How is the vibrations problem solved? Normally with superconductors we are interested in continuous long existence for the magnetic field. Like for example, if you float something in the air, you don't want it to fall every now and then. But here, because the pulse is very short, I think intuitively that there is no meaning to the movement of the particles of the copper wire. It's like taking an instantaneous snapshot, okay, like click with the camera, snapshot, instantaneous snapshot, where you freeze the movement of what you are photographing. However, maybe my intuition about this can be wrong, so if we do need to stabilize the platforms of this ring, the second ring, water surface ring, then one option is with drones. I really dislike drones, but we are trying to save the world here. So see this video of the drones that can catch a ball in a net. They hold together. Then they can be programmed to hold something in a fixed place when there is side wind, which is a similar problem. When a drone's battery is running low, he is replaced with another fresh drone and flies to recharge on the closest chip. The Astounding Athletic Power of Quadcopters by Raffaello De Andrea by TED, TED. This is the YouTube video, I'll put in the description. Another solution is to float the wire on air flow, like here. another video, how to float a ping pong ball on air. The Conda effect by Physics Girl. I'll put it in the description. Some of these methods here can also prove helpful. Wikipedia, hoverboard, this symbol, hashtag real world. Another possibility, if we need to lift a smaller weight like just the thin copper wire itself, then maybe we can use levitation by sound wave. Wikipedia acoustic levitation. I'll put on the links in the description. Another method, which I don't know if it's practical, but if it works, doesn't require electronics to synchronize these engines in different directions, which is a major advantage for us since the ring itself sends a magnetic pulse which might act as an EMP and fry electronics in the ring's vicinity, is to use some liquid that flows more quickly than water, less viscous than water. If we make a bath or pool of this material and float the buoys inside the liquid, inside this liquid, we can rest the wire on these floating buoys. For example, acetone is 3 times less viscous than water. Wikipedia list of viscosities, other liquids. Acetone is also flammable, so perhaps it's not the best idea to put it near strong and suddenly changing magnetic fields. But you get the idea. Like you have a jar and it's half filled with honey, and on the top of the honey you put water. So if you tilt the jar and then restore the jar to its original position, the water will respond much faster than the honey. So the less viscous fluid, the water in the jar or the acetone in the bath, will compensate for what the more viscous fluid, the honey in the jar or the water in the sea, does. Okay, it averages this thing. If we want a cryocooler, we talked about it, that doesn't touch what it's cooling, I read that there is something called pulse tube refrigerator. Maybe this will help. Wikipedia, pulse tube refrigerator. I'll put it in the links. If not, then we can use the redundancy shifts. One wire is working while the others are resting, like we described in the section about the first ring, ocean floor ring. Okay, clocks and synchronization. This is the last part. Since we turn on the electrical current only for a microsecond each time, we need to make sure that all the rings are activated simultaneously. Remember all the rings. In that same split second. This can be done by atomic clocks. Wikipedia atomic clock. So to sum all this up, the 3 rings together generate a periodic pulse that is aligned along about 10 kilometers, the total distance between the uppermost and the lowermost rings. And so this magnetic field continues down into the ground, and we do something equivalent to the South Pole, which is also synchronized with what we do in the North Pole. So this keeps the heart of the Earth functioning properly, and that's why I called it a pacemaker. Okay, so that's my invention, and thank you very much. I hope it will record because it's really long. Thank you very much. Bye bye.